So tonight, we're going to look at a segment of evolution. And one of the things that is always confounding is that we know there are animals and plants that have co-relationships. They call them symbiotic relationships. That certain plants and certain animals cooperate to the mutual benefit of both. And evolution has a very hard time trying to explain this. They have a word for it called coevolution. And tonight we're going to talk about that and some other things. So fasten your seatbelts, and I want to welcome everybody who's tuned in on the internet. Thank you so much for joining us tonight, and I hope this presentation blesses you. Our mission statement: we are the Biblical Creation Science Ministry at Godspeak in Newbury Park, California. And our mission is to exalt Jesus Christ, teach the Bible, equip the saints to witness to people, and actively disciple the world based on the Matthew 28, 19 through 20 verses. And as a corollary to that, what we want to do is actually, a corollary is we want to show the truth of the Bible and special creation by examining the evidence of science. So this is science-oriented, but it all points back directly at the Bible. And so a quote that I pulled of many, one of many in the Bible, when Job is talking to God, and God is admonishing Job for having some shakiness in his faith. He asked Job, "But ask the animals, and they will teach you, or the birds in the sky, they will tell you, or speak to the earth, and it will teach you, or let the fish in the sea inform you. Which of all of these does not know that the hand of the Lord has done this?" So God is telling Job to look at the animals, to consider what they do, how are they made, how do they interact with their environment, how they interact with their species. And does that talk to a designer, a God that created, or does it look like it happened all by chance, by the roll of the dice? So that's what we're going to be thinking about tonight. And one thing, there's often criticism that is lodged against what's called creation science. And people that are trying to talk against it, they say, "Oh, what you're saying is, you're just saying that when we don't know what happened, if there's some mystery that we haven't yet discovered by science, then you claim God did it." And this has been given a name. It's called the God of the gaps. So God fills in the gaps that we don't know. But they say over time, science will discover all of these facts that relate everything together. So it will all be known to us in the future date. But this is really not what creation science is saying. The creation science is saying there are two explanations that we see for life on Earth. And one has to do with evolution and humanism, and they have an explanation for that which is observed. And on the other hand, diametrically opposed to that is creation and the Bible, and that has an explanation for what is observed. And in science, there's a concept of competing ideas. When you have the method of multiple competing hypotheses, then you take and you put the evidence in analysis, and you analyze the data, and you say, okay, if there's two possibilities, does the preponderance of the evidence point to one possibility, or does the preponderance of the evidence point to the other possibility? It's something like a court case when you're impaneled on a jury and the lawyers and the judge tell you, look at all of the evidence with a clear mind, without bias, and decide, does the preponderance of the evidence point to the person being guilty, or does the preponderance point to the opposite of them being innocent? And that's exactly what we're doing here. We're taking the evidence of science, we're looking at it, and we're asking, does it fit evolution or does it fit creation? So Charles Darwin wrote his famous book, The Origin of the Species, in 1859. And I have there in the subtitle, there's a site that has the full book online for free. And it's put on the internet by a group called Living Waters. And that group is a Christian group. And the fellow who is the head of that, Ray Comfort, has written a 50-page introduction to the book Origin of the Species, which is copied word for word. And so if you want to read it sometime, you can. It's available. And Darwin theorized that all living things evolved from a common, simpler life. And so you go backwards in time. If you run the clock backwards, then complex life got simpler and simpler and simpler and simpler until the simplest kind of life that we know of is a single-cell creature, which might be like an amoeba or a protozoan or a bacterium. They're all single-cell organisms. And then he theorized going forward that organism would have changed over time through mutations, those copying errors, and as they accumulated, some of the copying errors were beneficial and some were deleterious. So the beneficial ones would all add up and there would be a new, better creature, and then that creature would reproduce and it would make a better creature and better creature and better creature into the future until you get more and more complex beings. But this is not what we see. People since the mid 1800s, that's over 150 years, almost 170 years. They've been trying furiously to do laboratory experiments that show this progression from lower to higher animals, and all of the attempts have been unsuccessful. And they've artificially stimulated, because mutations happen very infrequently. You can think of it sort of as a birth defect. That would be a mutation. And most of the birth defects that we know about are negative. They affect the human population in a negative way, and they also, by and large, affect the animal population and plant population in a negative way. And so what they're saying is, but his basic premise of all of these tiny changes, his theory had each one of the changes. You don't have an alligator that lays an egg, and that alligator egg hatches and out comes a bird, a completely different species. You have an alligator with a slightly different body structure. Maybe the tail is longer or the mouth is bigger. And so those small changes all have to add up, and that's called microevolution. And then when you get a change that's so radical that you go from a very simple animal to a much more complex one, say going from a reptile to a bird, that's called macroevolution. It's a big change. We know micro means small and macro means large. So it's a macroevolution, and that we don't see. And it's just an extrapolation. And in Ray Comfort's introduction to the theory of origin of the species, he made the example of saying we observe a car that can go from 0 to 60 miles per hour in 6 seconds. And then we say, okay, and we see a lot of cars that can do that. So we say, okay, well, I think in maybe 1,000,000 years, if we let the cars evolve, that we would see a car that could go from 0 to 6,000 miles an hour in 10 minutes. So we just draw that straight line, between 0 and 60 miles an hour, and then just keep extending it higher and higher over more time. And then you get to 60,000 miles an hour. And oh, by the way, the car has changed from a car to a rocket ship in order to make it go 6,000 miles per hour. And we know that isn't true. People have been trying, as I said, to change species for over 150 years, and all of the attempts have been utter failures. And one of the quotes, Darwin he wasn't being dogmatic in many places. He kind of posed questions and then answered it himself. And so one of the things he's written in his book, and this is a direct quote from Origin of the Species, is, and it's quoted, if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight small modifications, my theory would absolutely break down. And so he recognized that it needed small changes. You can't have these giant leaps from one animal with a body type to another, from a reptile to a bird. The structure of the bodies are completely different. So he insisted that his theory required very small changes. Well, the answer to his proposed question actually has been answered, and it's called irreducible complexity. And this is a powerful challenge to Darwin. So let me show you what the example of irreducible complexity is. So if you look at a mousetrap as an example of a complex machine, and the mousetrap is composed of various parts. It has a base, usually made of wood or plastic. It has a spring in order to give force to the operation of the tool. It has a hammer, what they call a hammer. That's the thing that catches the rodent by the neck. It has a catch that holds the food tray in a certain position. But that catch is very tenuously held so that if there's food on the food receptacle and something touches the food, then that lets loose the catch, and the hammer swings down under the force of the spring and captures or kills the rodent. But if you take away any of one of those pieces, so it's a irreducibly complex machine that all of the parts have to be there for it to be a mousetrap. If you take away the base, the pieces of metal have nothing to hook onto. If you take away the spring, then there's nothing to forcefully slam the hammer down. If you take away the food, the rodent has no reason to come over and take, move the bait lever arm. So all of those things have to be in place. And when you look at the biological world, it's filled with these irreducibly complex mechanisms. And one of them is what's called the flagellum of bacteria. So tiny one-celled creatures need to move around in order to capture food. And if you look at a bacterium, they have what is the equivalent of an outboard motor that propels them around in whatever fluid that they're living in. So the motor has a stator, it has a rotor, it has a U-joint, it has a drive shaft, it has a propeller. And all of these things are operated by the flow, the internal flow of electricity through these molecular-sized pieces inside the bacterium, and that allows the tail to spin at high speed and to propel the bacterium one place to another. Other bacterium have what they call cilia, what are like hair-like appendages on the outside of their body, and they have the ability to move those cilia, and again, that moves them so that they can go from one place to another to capture food in order to sustain their life. Another example would be the human eyeball. If you had a human eyeball, you have to have all of the parts of the human eyeball. If you didn't have a pupil, there would be no way of letting the light in. If you didn't have the retina, you would have no way of capturing the light. If you didn't have the nerves at the back of the retina that transferred the light energy into electrical signals for the brain to sense. Then you couldn't see. If you didn't have the fluid in the eye, then your eye would collapse and you couldn't see, on and on and on. So there's a whole long list of things that are required to have a human eye or an animal eye. And sometimes animal eyes are even more complex. If you look at an insect eye, they have thousands of lenses where we only have one. So eyes are another example of irreducible complexity. And so that addressed that one thing that Darwin was troubled with, and he didn't understand about irreducible complexity. He understood the eye was complex, but he thought there would be some way that it could have evolved. And it doesn't appear that there's any mechanism to allow an eye or even a flagellum of a bacteria to evolve. Then the next thing, so another concept that Darwin struggled with, and he admitted it very openly in his book, was the idea of behavior. How did instincts evolve? So again, his quote is in the black. Many instincts are so wonderful that their development would probably appear to the reader a difficulty sufficient to overthrow my whole theory. And so he was troubled by that, and he came up with some ideas about habits becoming somehow ingrained into the organism, and I'll explain later why he believed that. But in this talk, I'm going to talk first of all about symbiotic relationships, and this is the idea of the coevolution, so I'll talk about that. But later in the talk, I'm going to go back and address this question that Darwin had in his own mind of behavior of living creatures, and to talk about the special behaviors of creatures that really have no way of evolving. And there's multiple features in each animal that has really no way of evolving. So I wanted to give one example of coevolution because it might be a term that you haven't heard of before. One example, this is from the UC Berkeley Evolution 101 website. So Berkeley, University of California at Berkeley has an evolution website. They call it Evolution 101. And it's a basic concepts of evolution for high school kids and freshmen in the college. And so they point out, they understand that there's different organisms that cooperate in different ways. And so they have identified one of the organism pairs. One is the South American acacia plant, and the other one is a variety of one of the local ants that are in that same area as the acacia plant. And so what happened, they say, is this acacia plant evolved from another plant, older plant. They think the acacia plant was somewhere in the evolution of the plants on Earth. And so it has a very unusual feature that it has a hole that allows air and other creatures to crawl inside this tiny hole in the leaf that's like a house. And so it offers this hole to whatever organisms are around as a place of refuge, and also in that hole there's availability of the nectar and the sugar that the plant generates. So it's a perfect feeding spot for insects. So if you're an insect and you can go in that hole, then you can feed yourself and you'll be safe. There won't be any predators that can eat you because you're inside the plant. And then when you need to go out, you go out. So that's how the insects benefit. But what are the benefits of the insects to the plant? Actually, there are in that same area, they call them vampire plants. These are plants that are parasitic plants that actually attack other plants. So if the vampire plant, it's actually like a vine that grows, and it grows and grows up the plant that it's attacking, and it attaches itself and drains the nutrients from the plant and eventually kills it. And so there's no defense that the acacia has for that. But it turns out the ants love to eat that plant, that vine. So they've studied this by filming the plant for long periods of time. They find the ants also, they attack this vampire vine that attacks the acacia plant, and it protects the plant from that predator. And also there are other insects and larger insects that can attack the plant, the acacia plant, and cause it to be harmed and die. And it turns out that, again, because of the numbers of the ants and their ability to swarm and things like that, that they actually can chase away predators that are bent on trying to feed themselves off the acacia plant. So there's two ways. Both the ants attack the plants that are parasites, and they also attack predators that are going to attack the acacia plant. And so this is really amazing. This is a mutual beneficial relationship. And down at the bottom, the people at UC Berkeley say this system is probably the product of coevolution. The plant would not have evolved hollow thorns unless their evolution had been affected by the ants, and the ants would not have evolved herbivore defense behaviors unless their evolution was affected by the plant. But I'm not really sure how that is, because we know, and I'll show you, that we know DNA is what affects the structures and how animals evolve and how the structures of the animals are. So I don't see how a plant can affect the DNA of an ant, or the ant can affect the DNA of the plant. So let me go to the next slide. This is a scientist, a French scientist by the name of Lamarck. And he had a theory that was popular in the 1800s, around Darwin's time. And Darwin believed in his theory. And it's called the theory of inheritance of acquired characteristics. So one of the things that Lamarck was trying to figure out is the giraffe. So he said, well, I think there was an animal that was a longer-necked animal, maybe like a cow or something like that, or maybe an antelope. It had a longer neck, and it could eat the grass on the ground, but it really preferred to eat the leaves in the tree. And so it stretched its neck and stretched its neck, and then it died. And then its offspring that it had before it passed away, it was born with a longer neck. And so that animal was enticed by the leaves, and it stretched and stretched and then had an offspring, and it died. And then finally, the last of the offspring had a long enough neck that they could reach the succulent leaves at the bottom of the trees. And so over time, you could take a characteristic that was a physical characteristic, like stretching your neck, or oftentimes you see them postulate that reptiles wanted to fly. So a reptile would get up on a branch and it would see a bug over here, and that reptile would jump, and then it would try to wiggle its arms and it would crash to the ground, but it didn't get the insect, but it almost did. So when it had its offspring, those offsprings had the same desire, but it had maybe feathers on its arms, and it got a little further and then a little further and a little further. This is preposterous. You know, in order to change the body part within any animal, you have to have the DNA code. You have to have the information written in the DNA code that allows that to happen. It's programmed in, just like you have an app in your telephone or a program in your computer. It doesn't morph itself into something else. You have to put the program into the computer that allows it to do more than it was doing before. You have to go to the store or download another program that enhances the ability of your computer. So modern genetics theory, we now understand that the information is in the DNA code, and that determines the traits of the offspring. So acquired traits such as large muscles that a bodybuilder, if you had a bodybuilder, Arnold Schwarzenegger, when he was in his prime, he was winning championships for bodybuilding. When he had a baby, the baby didn't come out covered in muscles. It was a fat, pudgy little baby, because that's what it was designed for. And there were French scientists in the time of Lamarck that took mice. And they took mice and cut off the tail of the male and cut off the tail of the female, and then mated them. And they came out, the offspring came out with tails, and they cut those off. And then they mated those, and they cut those off. And they went generation after generation after generation, and every mouse that was born had a tail. And so they were confounded. They really couldn't believe how this acquired trait being passed on from generation to generation was possible, because they didn't understand DNA. That was to be discovered in the 20th century by Crick and Watson. So that speaks directly to this idea, and as I said, Darwin believed that Lamarck's ideas were correct. So he thought just by an adult acquiring a trait, then when they had their baby, that trait would be passed on and on and on and on, and that would be the small change. So that's no longer, and in fact, this has been repudiated. Scientists, everyone agrees that this theory is no longer correct, but it was one of the cornerstones of what Darwin was talking about. Now let me talk a little bit about coevolution. Here's a shark that's co-evolving with a lot of little organisms that stick to his body. So to make it precise, we want to try to be precise with our science here. Coevolution is when two or more creatures work together for the benefit of both. How does evolution explain two creatures evolving simultaneously at the same place? They have to be at the same place so they can interact, and at the same time. We're told that evolution happened over a 3.2 billion year time span, and the time where complex creatures were formed was really in the Cambrian explosion, which is 500 million. So 500 million years, how do all of these things occur in the same location and at the same time in order for this coevolution to happen, which again violates the principle of the DNA controlling the inheritance instead of Lamarck's idea about acquiring it. So let me go on to the next, give you some examples. So here's one of our favorite examples. These are two organisms. One is the clownfish, the brightly colored orange and white fish we have in our fish tank, and the sea anemone. And so these two animals live in a symbiotic relationship, mutual beneficial relationship. And the idea is that the anemone has a powerful sting at the end of each one of those little finger-like projections at the tip. You can't see that in the photograph, but there's a tiny little stinger at the end of that tip. And the clownfish, you see, they bury themselves inside there. They swim through that anemone and they bury themselves inside of it because they have, they have an immunity to the sting of the anemone, and also they have a coating, a mucus coating. When they look at these fish in detail, there's a thick mucus coating that covers their body, so the stinger is less likely to penetrate that mucus in order to get into the fish's body. So that fish has a great friend. When it's in trouble, it goes to the anemone, and no matter what's chasing it, even if it's a much larger fish, that thing backs away because it's going to get stung severely by that anemone. And but there's another fish that also has that immunity, from the anemone, but it actually is a fish that likes to eat the anemone. It is an enemy of the anemone. So it's called a damselfish. And so it's immune to the poison also, but it, instead of being a friend of the anemone, it wants to eat it, wants to kill it. And so what happens is when the damselfish comes over towards the anemone, the clownfish attacks the damselfish. So the clownfish acts as the security guard and defender of the anemone, and then when the clownfish is being chased by a predator, it's being befriended by the anemone. And how can that happen? How could that co-evolve? The oceans cover 71% of the Earth's surface. The average depth is 2 miles or deeper. That's a very big ocean. And to have that clownfish to be exactly at the right place where those anemones live at the right time when the anemones are evolving, and it's evolving at the same time from another fish that presumably didn't have any immunity to the anemone sting, that's really hard to believe. But there's better cases. So that's one. Let's take the case of a shark. So up in that right-hand corner, I've got a school of fish, and there's a shark going through that school of fish, and you see the fish are darting in every direction, but the shark has got its mouth open, so it's probably got a pretty healthy lunch of a bunch of fishes that repeatedly, this is, it's just a loop showing this shark swimming through the fish. But when you look at the shark, there's certain kinds of fish, 2 kinds. One's called the pilot fish, another is called the remora. And these fish actually are beneficial to the shark. And they'll attach themselves to the body of the shark. If you've ever felt a shark, how many people have felt a shark? It's kind of a rubbery skin. I touched one. Has a kind of a rubbery skin. So that rubbery skin is clean, needs to be cleaned from bacteria. And so those two fish do the cleaning service. But it doesn't accept all the fish. It only accepts those 2 fish. So how many times as the shark is evolving and the pilot fish and the remora fish are evolving, how many times do you think this might have happened? Oh, I'm a remora fish. I want to go make friends with this shark. Yeah, you make friends in his stomach. So, you know, the chances the shark is a fearsome predator. We all watch a television show called Shark Week, so we know it eats everything. And it's amazing that how a species would be able to make friends with a shark that's evolving to be the killer of the sea. There's also other examples. Here's a couple of more examples. The Cape buffalo, and there's a bird, I think, that is an insect-eating, parasite-eating bird. So the Cape buffalo is actually considered the most dangerous animal in the world, from the standpoint that it kills more people than any other animal, any other wild animal, more than lions, more than tigers, more than hippopotamus. Hippopotamuses are very dangerous, but I think the Cape buffalo and the hippopotamus are 1-2 in the death rate for humans. But that bird, and it's the same kind of bird, it isn't just any bird there. That bird has made a pact with the Cape buffalo and just comes and it sits on it. I have pictures of a whole herd of the birds sitting there pecking on the animal, and it's just benignly taking it, kind of like a massage, and it's getting cleaned up in order to keep itself free from lice and other organisms that would torment it. And of course we know things like hummingbirds and bees and other birds pollinate flowers without that interaction between the flowers and the insects and the butterflies and the birds, we wouldn't have the plants that we have around the world. 1/3 of all of the plants are pollinated by a partner. So the wind does some pollination, but the other 1/3 are by animals. And here's another interesting symbiotic relationship. This is a yucca plant, and there's a insect called the yucca moth. And the yucca moth goes and it lays eggs on the yucca plant. So the moth lays the eggs on the plant, and it buries the eggs in pollen that it has captured from visiting other yucca plants. So it takes the eggs and they put it on the yucca plant, cover it with pollen from another plant. So now the plant gets pollinated. The plant germinates seeds from the fertilization process, and the moth then flies away, and those eggs hatch and turn into larvae, and the larvae eat the seeds. But they don't eat all of the seeds. The larvae eat just a sufficient number to give them sustenance and to grow, and then go through their metamorphosis to change from a little worm-like creature into a flying creature. And that happens so that the plants are preserved, and they go through their life cycle, and they're refreshed in their life cycle, and also the moths. And this happens specifically with that moth and with that plant. No other of the insects go and do that. So the two are codependent. They wouldn't survive, they wouldn't last if they, and couldn't survive if they didn't have that pollination take place. So I'll skip. There's also another really interesting one. This is called the relationship between ants and leafhoppers. So there's a bug that's called a leafhopper, and it's able to go along plant, the stems and leaves of plants, and it sucks nourishment out of the plant, and it generates a sugary substance that it leaves as kind of a trail after it's gone. And the ants go and they love that sugary substance, so they collect the sugar, and that gives them sustenance. And they actually, they have filmed them, and it's like the ants take care of the leafhopper. It's like a cow. You know, they capture one of them, and then they keep them kind of under control, and the leafhopper is eating and getting its food. And any thing that goes to attack the leafhopper, the ants, again, because they can swarm and they can do so many things that are, attack the leafhopper's enemy, then it protects. So again, the leafhopper is feeding the ant, and the ant's protecting the leafhopper. And here's a croc. They love eating birds. They eat pretty much anything. Here's a croc eating a fish. Here's a croc eating a croc. Here's a croc eating a shoe. So they have a pretty wide-ranging palate. They will accept most anything. Here's a croc that has this tasty little bird that cleans its teeth. It's its dental hygienist. So this bird is called a plover bird, a plover bird, and it goes and flies over, lands, and crawls into the croc's mouth. The croc opens its mouth dutifully and lets the bird pick out all of the pieces like a toothbrush, brushes its teeth, and then when it's through, it flies away, and they're both in business. I think that's called a conundrum. How long did it take that bird flying into that crocodile's mouth in order to convince the crocodile it was trying to clean its teeth, not become its lunch? Does that make sense to you? Anybody see the merits? Why doesn't the bird just go get some food, worms, over, not inside the crocodile's mouth? So it's really, it doesn't make sense. It doesn't make sense from the standpoint, we know the behavior of crocodiles, we know the behavior of birds, and we know that what the problems are. And it doesn't make sense. It doesn't correlate with coevolution. It correlates with God gave these animals both at the same time instincts in order to let them cooperate. So God implanted in the DNA, in the brain of the organism, the ability to react in a certain way that would be what he wanted to have happen. God wanted to have these symbiotic relationships in order to pollinate the flowers, in order to have the yucca plants and the yucca moth survive, in order to have the shark have its skin cleaned. So God put those behaviors, implanted them into the organism in order to make that happen. Here's another good one. The termite and the gut bacteria. So termites are pests that we all know about when we buy and sell a house, termite inspection. And it turns out that the termite, they have found through analysis, cannot digest cellulose, which is wood. So if they ate cellulose and without the organism that lives in their stomach, the bacteria, they would die because they would be full of something they can't digest, and so they would die. But it happens that there is a enzyme called cellulase that is in the gut of the bacteria that is in the gut of the termite, and that material, that enzyme, breaks down the cellulose into something that the termite can digest and use as food. So you have a termite that has something inside itself that isn't part of the termite, that is there in order to allow it to eat its natural food, which is cellulose or wood. So which came first, the termite or the enzyme? You know, if the termite didn't have the enzyme, it would be dead. The enzyme, just by itself, it wouldn't be doing anything. So you need the two of them together. So God put the enzyme inside the termite, much to the chagrin of people who buy and sell houses sometimes. But that you need to have both of them at the same time, at the same place, in the same location. And that seems preposterous to me, that those things can evolve in synchronism. You know, if one evolves in the year 10,000 BC, and the other one evolves in the year 10,001 BC, that's a year apart. They're going to die because the lifespan isn't that long. So they have to be simultaneously, absolutely simultaneous. Okay, here's the link between insects pollinating and butterflies pollinating. And they had a big crisis about 10 years ago in Europe. They found that the bee population was dying for some reason. I think it was a fungus that the bees were experiencing until they took control of that. The bee population dipped, and when the bee population dipped, then the flower population dips because they're not being pollinated. And there was a big crisis in growing flowers in Europe, which they are very into. And so you have to have the bees, when they get into the part of the flower where the pollen is, they get that stuck. This is microscopic photos of pollen. It sticks to the feet of the bee And when it's gathering the nectar to make into honey back at the nest, it's getting all of the pollen on its feet. And so when it goes to the next flower and the next flower, that's a perfect mechanism to transfer that pollination, and the sexual reproduction occurs. Okay, so then this next one. Here's a flower. And they've determined by looking that the pollen of this flower isn't up here. It's way down there. So how is something going to be able to pollinate that flower? Well, wouldn't you know, there's a long-nosed fly that just happens to live in that same area that this weird flower is. And his nose is just slightly longer than the distance between the opening and where the pollen is down here. And so this long-necked or long-nosed fly can get its nose down in there and do the pollination from flower to flower. And that's a pretty amazing, you haven't seen many flies with noses like that. And then here's the last one. This is kind of a dirty trick. Here's some of the flowers actually trick their pollinators into thinking that they can have sex with the female of the species by growing to look like the female of the species landed on the tip of the flower. So this flower here has what looks like the body of a female wasp landed on this end of this stick. And the male wasp would like to reproduce with her. So he comes over and flies over and lands on the flower and tries to reproduce, but he's frustrated because it's a flower, not a wasp. So he gets pollen on his feet and he flies away in anger and goes around, finds another one and another one. And these are all tricks, because it turns out the male wasp, it hatches about 2 weeks before the female wasp hatch. So nature and God have made the wasp cycle to be in concert with these flowers, so that the male wasp comes out, he's looking for a mate. Oh, there's some over there. Flies over there, tries to mate with the flower, gets the pollen, goes to the next one, gets the pollen, gets the pollen. He can tell the female from a flower once the females are available, but he's so anxious when he comes out of the stage where he's become a full-fledged male wasp with the reproductive power, he's going to mate with anything he sees, you know. Kind of like some of the guys I know. So this is a way that God has of reproducing these orchids. They're actually orchids. They are pollinated by the male wasp because they want to have reproduction with the female, but there's no females, so it goes with the flower. So I think all of those examples, I think, convince me beyond a shadow of a doubt. If I look at the evidence that I have, it's impossible for me to say anything other than I think the vast preponderance of the information that is available from science says that those items have to be made at the same time in the same place, and that will happen by creation. It won't happen by evolution and chance. Okay, so let me pursue on to the next last few slides. So evolution of instinct. So we're going to switch over from coevolution to evolution of instinct. And so I think evolution of instinct to me is probably one of the most amazing facts, and it's only really surpassed by the evidence existence of life itself. You know, the instincts of all of these creatures are so amazing. So let me jump over. So there's two ways that offspring can get information from in order to live their life in the animal world. One is they can learn a behavior by observation, teaching, and communication activities from their parents. So it's do as I do, or monkey see, monkey do. They copy what their parents do. Or in addition to that, there is instinct when the animal is born with that knowledge at the time of birth. So examples you might want to have, what are the examples of teaching? They found that polar bears teach their cubs how to fish. They found out that orangutans teach their young how to build nests. They found that lions teach their cubs how to hunt. And the proboscis monkeys is ones with the big nose. The mother teaches the young which leaves are safe to eat. So there is teaching. It's, the mother or the father will do something, and then the cub or offspring will copy it, and they learn. But there's a whole bunch of different instincts that are there from birth. And I'm going to give you an example of many of these. So let me jump to this one. This is a leatherback turtle, sea turtle. And the mother comes up on the shore and swims up on the beach and digs a hole and lays her eggs in the hole, in the sand. And 6 weeks later, and the mother goes back out to the ocean, never to be seen again. 6 weeks later, the eggs hatch, the little turtles fight their way up to the surface of the sand, and they have a choice. They see the beach on one side with the bushes and the reeds and everything, and they see the ocean on the other side. 100% of the time, the turtles head towards the ocean as fast as they can, from the standpoint that their predators are birds that are flying overhead, and there's only about 50%, they estimate, of the turtles that make it from being hatched into the water. Or they also face predators, but not as many as the birds. And that happens 100% of the time. How do the turtles know which way they should go? Why don't they decide to go up on the grassy beach part? It's got sun, it's nice. It's instinct, built into the animal by God from the beginning. Here's another one. Here's a baby, a human baby. If you ever have had a baby or a grandchild and you buy the little baby a rattle, and they get the rattle and you shake it and they hear the sound, they are giggling, and you hand them the rattle and they shake it and they giggle again. They love the sound of the rattle. It's music to their ears. If you do that same thing, what's called a kangaroo rat, their natural predator is the rattlesnake. And you can take a kangaroo rat that you've captured, and you take it to the lab and you have babies, and you raise those babies and they have babies, and you raise those babies and they have babies, and you take the babies from the last third generation and you have them in the cage, and you go up to the cage and you shake a rattle by the cage. Those kangaroo rats jump and run in every direction. Their life is on the line, and they know it by instinct, because they have tuned into their brain. They don't copy it from mom, because they're third generation laboratory mice. They've never seen a rattlesnake in their whole life, but when they hear that sound, they go crazy. So that's an implanted instinct into those kangaroo rats. Now here's some even more complex behavior. Here's some birds. They're called golden plover birds. They summer in Alaska and they winter in Hawaii. So they got a pretty good life. The problem is the parents go to Alaska. They mate in Alaska, and they lay their eggs, and the birds can't swim. So they lay their eggs, and then as soon as the birds hatch and they're able to fly, as soon as the little hatchlings are able to fly, the mother and father take off towards Hawaii. And the little birds are like, Mom, Dad, where did you go? They're left. So what they do by instinct is they start eating like crazy. So they have to build up their body weight, their body mass in order to fly. They know instinctively they have to fly. So they eat like crazy and they build up their body weight to 200 grams. And so they have 70 grams of fat on their body. And the bird can't fly. They found out through doing tests that a bird that weighs less than 130 grams weight can't fly. So it's got 70 grams of fat to burn. And so the birds take off when they are 200 grams and go headed toward Hawaii. And they would run out of energy in about 72 hours into the flight. The flight to Hawaii at the speed that they go is about 88 hours. So 72 hours into the flight, if they were just single birds flying by themselves, they would fall in the ocean and drown because there's no land to land on. The solution is they fly in a V formation. They also fly like the Canadian geese in the V formation. And what does that do? That's like the NASCAR people when they draft in their NASCAR races. They get one right behind each other, and there'll be one that goes up to the front of the V, and that bird flies and breaks the wind for the other guys behind him. And then he falls back to the back position, and another bird takes his place, and they switch. And by time sharing who's in the lead, burning the energy, they can all make it to Hawaii. They can fly. They have 5 hours additional reserve to fly so that they all make it to Hawaii. They go to the same place and they meet up with their parents and they made it. But they're not taught. They have no idea which direction they go. The mother and father didn't write a map and leave it in the nest for them to use. So they were able to fly on instinct. And when you look at the challenge of that, the directional accuracy of the bird is on the same accuracy of the navigation of a jumbo jet liner. So it can fly within a few degrees of the perfect direction and understand the winds over the ocean are blowing and there's storms they have to go through and everything. They can navigate through all of that stuff and get to exactly the right, and this is through days and nights, so they're flying at night in the rain, and they still get to the place that God intended them to by planting that in their brain. I think that's pretty remarkable. The same thing for eels. It's a known fact that eels, freshwater eels, from both the east coast of the United States and the west coast of Europe, all swim to the location near Bermuda in order to reproduce. So they leave their lakes and their rivers and swim into the ocean. They all gather around Bermuda. They then, when they hatch, they look like this little triangular shaped thing, and it grows and grows and grows, and finally it looks like an eel. And when they get to that size, then they all head back to where they came from, where the parents came from. The parents die after they mate. So the parents don't go back with them. So the parents mate, take care of the kids for a while, they die, and before the kids get big enough to go back home, the parents die, they're dead, and the kids go back to exactly the same lake or river that they were in, either in North America or Western Europe. And you have the bird in Australia. It's called a mallee fowl. So the mother and the father mate, and they build a nest composed of compost with sand covering. The female lays the eggs, and then she disappears. So it's up to the father to tend the eggs. And so he tends the eggs, and he has the sand over the eggs, tends the eggs until they hatch, and then he disappears. And one of the features that they found by observing these mallee fowl is that the temperature within the nest has to be 94 degrees plus or 91 degrees plus or minus 2 degrees. So how does the bird know what the temperature is inside the nest? It turns out he has a little thermometer that's built into his beak, and that when he sticks his beak down in the sand, he can tell what the temperature is. If the temperature is too hot, then he kicks sand away to make the eggs closer to the surface. If it's getting cold, then he kicks more sand on top, so the compost that's below it is decaying and generating heat to keep the babies incubated. And he does that for between 60 and 90 days, and then the chicks hatch, and the father abandons them. And then when the chicks grow up, the males do the same thing. That behavior of measuring the temperature with their nose and adjusting the temperature inside the nest to be exactly what it needs to be in order to reproduce the species is built in by God into their being. So they know inherently how to do that. And then there's the idea of using tools. And I'll skip right to the pictures. You know, if you've ever gone to San Francisco, I've seen this in San Francisco, there's otters that live up by Fisherman's Wharf. And what you do is you see those otters, and they'll have a crustacean or something on the tummy, and they got a rock in their hands, and they're beating on that shellfish in order to crack it open. They can't pull it apart with their claws, but they can crack it open, and once it's open, they devour the inside. And the tusk fish, this is a tusk fish, it has the same thing. It'll find a crustacean, and then it'll put it in its mouth and whack it against a rock until it breaks open, then they can eat it. And here's a bird that's found a thorn, and this thorn, since there's holes, there's grubs inside this wood, but the beak of this bird is so short, it can't pull the grubs out. But it can put this thorn inside those holes and dig the grubs out with the thorn. And the ants also use tools. And until the 1960s, scientists said that using tools was a characteristic of human intelligence. They said, oh, animals can't use tools. That's what distinguishes people from animals. But it's not true. Animals know how to use tools too, because they were given that instinct by God from the beginning. And then another one I particularly like is something, animal bird called the Egyptian vulture. And this vulture uses a rock, a tool, that it loves to eat ostrich eggs. But if you've ever seen an ostrich egg, that egg shell is really, really thick. So that vulture can't peck through that shell using its beak. And so it gets a rock and it hits the shell in the same place over and over and over and slowly cracks the shell, and then all that inside is available to the vulture. And they put other vultures, other species of vultures in with the Egyptian vulture. And the Egyptian vulture gets a rock and it pounds the ostrich egg, opens it up, it eats, and then this other stupid vulture goes over and it eats. So they take the Egyptian vulture out, they put a rock and a ostrich egg in there, and the vulture just sits there and looks at it. Or pecks it with its beak. It doesn't learn how to use the rock. And then this is one of my favorites. This is called a archer fish. So this archer fish is a South American fish. And what it does is it shoots a little jet of water up to knock insects off of low-hanging vegetation into the water, and then as soon as that fly hits the water, this fish darts over and consumes it. But you notice this fish has some very unusual characteristics. When they dissect these fish, it has water sacs that are back of its gills. And in its gills, it has some bony plates that it can pull with muscles to compress those little sacs of water. And it has a groove in the top of its mouth that comes down as a hole. So with the combination of the water-filled sac, the bony material over the gill that can compress those water sacs. It puts its tongue in a place that makes it like a gun, and it shoots the water out of this squirt gun and knocks the insect into the water. So all of those things have to be there. The sacs, water sacs have to be there, the bony plates have to be there, the groove in its mouth has to be there, and it has to have the behavior of wanting to spit water out and knock the fly off. You don't see fish spitting water out often, right? And there's one more complication. If you know when you're looking at something that's underwater that the light is diffracted as it goes through the water. At the air-water interface, the light is bent. And you can see that if you go over to the fish tank, you'll see a fish. And if you're standing at an angle, you see the fish on one corner, and you see the same fish on the other corner. How can that be? They're two fish of the same kind? No. It's just that the rays are being bent, so you can see the fish on one side and you see the same fish on the other. So the fish, when it's shooting to knock off the fly, if you look, the fly is up here, but the light is bent. So if you were going to, the fly is on the twig, and what the fish, if it was a stupid fish, would say, oh, I got to squirt the water up here, but that wouldn't knock the fly off. You have to take into account that light is bent, so it squirts the water over there and knocks the fly off. So the fish has to know optics, or God has to program that into its brain, one or the other. We're checking that out right now. And here's another one. This one's from Nemo. This is a fish called the anglerfish. It's a very deep water fish, and it has a bunch of characteristics. It has an appendage on the end of its nose that sticks out, and most fish don't have that. It has a bioluminescent material inside this protrusion from its nose that glows in the dark, and the fish is a very slow swimmer. So what does the fish do? So the fish swims very slowly and then just sits still. And it turns on, it can turn on or turn off this light on its nose, and because it's so darn dark down where it lives, it turns on its light, and like every other creature, moths to a flame. Hey, what's that light over there? So all of the fish come swimming over, and that's exactly what they did in Nemo. If you saw that movie, they swim over, and by the time they're up close enough to see what it is, the fish got these giant teeth, clamps on them, and eats them. So again, you have to have the protrusion, you have to have the bioluminescent material, and you have to have the fact that this thing can't swim fast, so it can't outrace anything. It has to have its food come to it. That's pretty amazing. And then the final one is a snapping turtle. It looks like a rock, so pretty much looks like a rock. It's slow moving. And what happens is, I don't see how the turtle sees this, but his tongue looks like a worm. It has an orange streak on its tongue. So what it does, the fish goes to the bottom of the river and settles in, opens its mouth, doesn't go anywhere, and it wiggles its tongue, and it waits. And a fish or something will swim over to eat the worm that they think is sitting right on this rock. And when they get close enough to try to grab the worm, the rock snaps its mouth closed and consumes the fish. So I think those three examples, the archer fish, the angular fish, and the snapping turtle, it shows you have instinct, you have behavior, and you have physical features of the creature that allows this to happen. If this turtle didn't have the pink tongue, it wouldn't work. If the anglerfish didn't have that bioluminescent blob, it wouldn't work. If the archer fish didn't have those water sacs to shoot the water out, it wouldn't work. So it has to have both the anatomical features and it has to have the behavior in order to accomplish its mission. How can that evolve? Okay, so in conclusion, instinct that's tied to physical behavior and has physical apparatus that allows it to perform a life-giving function like feeding itself. Without the physical form, for all of these other behaviors, entirely useless. And without the behavior, the physical form is useless. So the inescapable conclusion is that both instinct and the physical form had to be there, created simultaneously at the beginning. And there's no amount of make-up stories or guessing or wishful thinking that can escape that. So I just want to finish with the Bible. In the beginning, God created the heavens and the earth. And we know from Genesis 1:1, it's not a long argument, it's just a statement of fact. In the beginning, God. And in the second quote from Genesis, God made everything. In Genesis 1:3 through 25, He made time, He made space, He made matter, He made energy, He made life. God made everything, and it was good. It tells us in the Bible. And in Genesis 2:1 through 3 tells us that God rested after He made everything. And He didn't rest because He was tired from His creation. He was giving an example because He knew that His primary creation, man, would need to have a day of rest. So, and to worship Him. So God made, as He says in the Exodus, the 10 Commandments written by God's own finger in stone, that there was 6 days of creation, 7th day He rested, and that day is dedicated to His worship, the Sabbath day. And then the last one is Psalm 136, where it says, God gets the glory for all His greatness. God made creation and pours forth His love on the animals, on the plants, and especially on we humans. So the last slide is, I'm asking you, God's most amazing creature is you. There's Marty. There's Ed. There's Mark. There's Jim. I didn't get everybody in there. So God bless you. I thank you, and I hope you enjoyed this.